Hi guys, it's your guy Olumide. Today we are gonna be talking about an interesting problem solving technique. It's the dynamic programming. So it's a problem solving technique that might look daunting at first, it might look complex in the eyes, but really we are gonna be it, considering what it is made up of, and also considering some commonly asked tech interview questions that can be solved by applying the dynamic programming technique. Some problem can be broken down into subproblems, where each subproblems is actually a simpler version of the main problem. These subproblems themselves can be broken down into simpler subproblems, and we are not new, or these things are not new to us, especially if we have some idea about recursion and recursive function, whereby we are gonna make recursive calls to each of these subproblems to solve them in similar ways. But in the recursion process, we found out that sometimes we actually generate and solve the same problem multiple times, which can be quite inefficient and redundant. And dynamic programming is actually the antidote to this, right? Because it actually store each problem as it solve them. So it stores them so that they can be used again. So in such a way that it ensures that each problem is solved at most one time, making it very much efficient than backtracking and recursion and other problem solving techniques. And this can greatly increase the efficiency of an algorithm. Dynamic programming is often perceived as challenging, but it actually follows a pretty consistent problem solving process that is best explained with an example, right? Like what I'm trying to say is that dynamic programming is best explained with different example instances, like by solving the problem, by actually solving DSA problems that involve using this technique, this DP techniques, right? But right now we are actually giving a clue to what DP means and how to solve the problem. So we are going to be considering some key DP terms, right? Some terms and paradigm that are used in DP. While in our subsequent video we will be touching real world examples where we apply dynamic programming. So one of the paradigm and one of the terms that we use in DP is the optimal substructure. So the optimal substructure or optimal substructure is the optimal solution to a problem that can be constructed from the optimal solution to its problems. Okay, what this actually means is that for a problem to be solvable using dynamic programming, it has to have an optimal substructure. And that optimal substructure, what it means is that we can actually solve the problem by solving its sub-problems. We can actually derive the solution to the main problem by investigating and then accumulating the solutions to its sub-problems. That's what the optimal substructure means. So any problem that actually involves you solving a simpler problem and then probably adding them together, joining them together, using it to attain the main solution, is actually solvable using DSA, right? So another one is the overlapping subproblems. Is another term. So that is if the subproblem are solved repeatedly using the problem solving process. So the first one is the optimal structure, which actually propose that the problem can be solved by solving its subproblems, right? By solving its subproblems. Why this overlapping subproblem here is actually not telling us that these subproblems can be solved repeatedly during the problem solving process, meaning that we just have to write the algorithm once, and this algorithm applies to solve each of the subproblems, which now will be used to solve the main problem. So right, we have an algorithm. The algorithm is very okay in solving the subproblems, and these subproblems in turn is gonna help us to solve the main problem. So that's it. So it's a situation whereby we have an algorithm that is consistent in solving the subproblems, meaning that the same algorithm here applied to this subproblem, to this subproblem, to this subproblem, and when we actually find and solve this subproblem, we can end up solving the main problem from these subproblems. So now we have the recurrence relation. So the recurrence relation is actually a formula that expresses the solution to the problem in terms of the solution to its subproblem, right? So it's actually key in solving a DSA in a DP problem. So we have the recurrence relation. It's like a formula that actually relates the subproblem to the main problem. It's actually a solution that actually is a formula or a solution that tells us that okay, this plus this actually give us this, right? So whereby this plus this plus this are the subproblems, and what it gives us is the main problem. So we have a relation like that. And then the base case, which is simply the simplest instance of the problem, where the solution is already known without needing to be decomposed into more subproblems. So the base case is actually just referring to the subproblem that can no longer have any more subproblem, or a subproblem that cannot be broken down into any more subproblem, meaning that when we come across that subproblem, then we've gotten to the base case, we return something tangible, we return something, and we cannot go further down. We can't perform recursion or DP beyond that point. So that's the base case. So in solving a DP in fact, in getting to know that okay, this is a DP problem, it needs to satisfy these two conditions at the top. The first one is that it must have an optimal substructure, meaning that it must be guaranteed that we can actually solve the main problem by considering and solving the subproblems, right? And then the second one is that it must have overlapping subproblems, which actually mean that this subproblem can follow the same pattern. We can solve them the same way, the same order, and after solving them, we can now use this solution to solve the main problem, or this solution is gonna actually lead us to the main solution. So those two conditions are important for a solution to be for a problem to be solvable using DP. So those are the two things we look for at each problem. So any DSA problem, we look at these two things. Does it have a structure such that we can actually produce the main solution from the subproblems? And then is the subproblem similar? Can it follow the same pattern? Can we have an algorithm that will solve each of these subproblems the same way? Like an algorithm that will run for this subproblem, run for this subproblem, run for this subproblem, that will eventually give us the main solution. Okay, so why these other two right here are actually the what we need to solve the problem. So fine, we've actually deduced that okay, this problem is solvable using DP, right? So now what we need is to calculate the recurrence relation and the base case, and then from there we are almost done with the solution. So let's consider a real world example whereby we apply the DP, the dynamic programming. So it's used in word segmentation, so whereby search engine use dynamic programming in a process called word segmentation. So when user enter a search query without spaces, DP is employed to determine if white spaces can be added to form valid words. So for example, given a query without space like best restaurant, DP check all possible ways to insert best restaurant to insert space. So it can insert space into the best restaurant as best and then restaurant, or best rest and, by solving each segment of the problem separately and storing their solution to avoid recalculation. So what this is trying to say is that okay, let's consider all these search engine like Google search engine, so whereby there might be some typo errors whereby we actually forgot to add space, white space, right? So now this word best, let's say that the user entered the word best restaurant, and what is going to happen is that the search engine is going to use DP, the dynamic programming technique, to add the space first to BE, and then to see if it's possible to add a space here. But you know, in the process of adding a space to BE, actually this word is actually not correct. Why? Because this is B strions, which is actually not meaningful. So it can easily apply DP to put the to do this. When you check out and say that the word doesn't make sense, it will backtrack and put the space here rather, and then it will just keep doing this and doing this. But one added functionality and one added advantage is that as it is putting it like this, it is storing the meaning of each of this word, of each of this segment of word, is storing them so that it can compare and contrast instead of having to do it again and again. The next time you want to put a space, it's just gonna look at where it's storing it at and try to say, okay, have we done this, have we done this, have we done this, and then it can use those words that is stored, right? So and this is actually a real world application in search engines. So we'll be considering DSA related problem, right, that are solved by applying dynamic programming technique. We are gonna be considering these particular problems in our subsequent videos, and they include climbing stairs, minimum coin combinations, amidst others. So do well to subscribe to our YouTube channel, to follow us on all our social media handle, so you don't miss any of these great videos. Thank you.